Hello everyone, welcome to pgtnetwork.com. This short video will teach you how to leverage visual scripting in PGT to quickly create smart and dynamic scripts. In this presentation, our goal will be to collect routing protocol information from Cisco devices, and we will build a simple script for this. The script won't be the smartest or fastest ever, but will demonstrate that anyone can implement a visual script easily, even with zero programming skills. Okay, you will need to perform some very simple coding tasks using Python to return the data that was collected from the device, but this will be super simple, I promise. When you get experienced and write more complex Python scripts, the Visual Script framework will provide great debugging support as well. This demonstration builds on the Cisco DevNet simulation network that can be downloaded from the website, so you can reproduce each step the same way as you can see it in the video. Now let's start scripting. To start creating a new visual script, just click on the Action menu item, then select the new Visual Script editor, then open a new empty editor. The Visual Script editor will appear. The editor is not really empty, but PGT will show you a template to demonstrate how a Visual Script looks like. A Visual Script acts like an active flowchart where each element have their own role in determining the actual execution path. A Visual Script may have only a single entry point. This is the red-colored oval start item at the top of the script. Depending on the script logic, the script may have multiple exit points or stop elements. In this case, these are the purple items at the bottom. For this demonstration, we will only keep the start item from the template and remove the rest. Now press and hold down the Ctrl key by moving the mouse to make a rectangular selection of items. Selected items will be highlighted. Now press Delete and confirm the warning message to remove the selected items. Let's move the start element a bit to the left, then double-click it to open the Properties editor. Switch to the Description tab to add the text that describes the functionality of this item. This text will be displayed when the mouse is hovered over an item. In this case, the text entered is not very useful, but adding meaningful description to elements in a more complex script makes orientation in the script easier. Now we need to add more elements to build the script. As we want to collect the routing protocols running on the device, we are adding a new element that can send the CLI command to the connected router and then check the response to make a decision. This is going to be the element named Simple Decision. Click Add Element menu item, then select the Simple Decision item. A Simple Decision item has two unique properties needing configuration. The first one is for the CLI command to be executed on the connected device. The other one, below, is for adding the text that the element will look for in the response received from the device. If there is a match, meaning the text is found in the response, the execution will follow the yes leg of this element. Otherwise, the no leg would be used to proceed to the next element in the script. In fact, this text pattern can be a regular expression to ensure maximum flexibility in building a match condition. As any element in the script, this one also needs a name and a display label. The name must be unique in the script and is used for internal references, while the label is the text that is displayed in the editor. In our script, we want to check first if BGP is running. Therefore, use the name check BGP for this element. For display label, simply just type is BGP running. We use the command show IP protocols include BGP to detect whether BGP is running on the device. The text pattern to check in the command result will simply be BGP. If BGP is running, the command output will contain this word. But in case it is not, then the command response would be empty. Now click OK to close the dialog, then resize the element a bit. Now we need to connect the start element to the simple decision using a connector. Select the start element, then open the script context menu, click Add Element, then select Add Connector. To glue the connector to its target, simply just click the simple decision element. When we detected that BGP is running, we want to perform some action for which we will need a command element. Select Add Element, then click the Add Command Element menu item. Let's name this item as BGP is running. and for simplicity, use the same for the display label. Turn off the demo switch, then click OK to close the command editor window. Now connect the isBGP running decision element to this new command element by adding a connector. When you click the connector target, the Visual Script editor will ask whether you are adding this connection as the yes or the no leg of the decision element. Click yes to finish attaching the connector. The label yes will be displayed on the connector. As we want to perform the same for both EIGRP and OSPF, let's clone the isBGP running element by using copy-paste. Then open the new element and rename all BGP references to EIGRP. Click OK to close the editor and then connect this new EIGRP decision element to the BGP checking element. As the yes leg is already consumed, this connector will be the no leg. Also, connect the BGP's running command element to this EIGRP checking element. This means that EIGRP check will be performed regardless the result of the BGP check. Only we do perform some action in the BGP's running command element if the BGP was running. As we also want to perform the same check for OSPF protocol, let's use copy-paste again to clone the EIGRP simple decision item, and then rename all of the EIGRP references to OSPF. Now connect the EIGRP checking element to the OSPF simple decision by using the no leg of the EIGRP decision. After this, we also need to clone the BGP's running command element twice, one for EIGRP and then for OSPF. Connect these cloned command elements the same way as BGP's running command element is connected. We are at the end of the script, so it's time to add a stop element telling the scripting engine that the script is finished. Connect this stop element the same way as we did for other command elements. In fact, the stop element can also perform the same set of actions a command element can, only you cannot add connectors to the script sourced from a stop element, making it really an exit point from the script. The next step is defining the actions that we want to perform by the command elements. Double-click the BGP's running element to open the property editor. In general, a command element can be used to send the given CLI command to the connected device, then process the response. The command can be a static command or may be constructed dynamically. Therefore, the text editor on this tab accepts both a valid code or a simple line of text interpreted as the command itself. But sending a command is also optional, and in this example, we will leave the space empty and switch to the main code tab instead. This tab is used to define the code related to this command element. This code can process the result of the command specified in the first tab, but can also perform any other processing. The Visual Script contains some predefined global variables that we can use to control execution flow and pass the result of the script back to the caller. The keyword global is used to make these variables reachable from any element in the script. Returning the result from Visual Script is done via the action result text variable. The text assigned to this variable will be presented on the scripting form in the command result column. Let's use this variable to enlist the name of routing protocols that we found active on the device. When this command element is called, we know that BGP is running, therefore assign the text BGP to action result. However, looking at the rest of the script, we have similar elements that will add the text EIGRP or OSPF to action result respectively. Therefore, to make the test looking like a list of protocols, we also add the comma and space at the end. Before closing the editor, let's copy this line of text to clipboard, as we will need the same in other elements. Now do the same editing on the EIGRP command element, extending the action result variable with the text EIGRP. Paste the command from the clipboard, but also change it slightly. Assigning the text EIGRP to action result would simply overwrite it, but we want to preserve its existing content, which might include BGP if was set earlier. Instead of the equal operator in Python, we use the plus equal operator to perform this action in a single step. Now close the editor and do the same for the OSPF is running command element. There is one more thing that we need to add. The action result variable has a default value of vscript processed successfully. We need to set action result to an empty string in the start element to avoid this text remaining in the result. When using action result in a command element, we always need to make sure that the keyword global is used to declare the variable. Otherwise, we would just be using another local variable instance named action result, and the value assigned to it would never be returned. And the last thing, some cosmetics of formatting the text written by the script. This is really an optional part and is only included here to teach a bit more of Python coding. So far, we have constructed the text to be returned as a list of protocol names. But at the end of the text, we will always have a comma and a space attached, which is not very professional. Let's also prepend the text with the text protocols running : To remove the comma and space at the end of the text, we can leverage Python's strip function, including the characters that must be stripped off from the edges of the text. By edges, we mean either the beginning or the end of the text. Apart from this, PGT scripting form will colorize the items executed, applying green or red colors, depending on execution succeeded or not. We can influence this from inside the Visual Script by assigning value to the script success boolean variable. This variable can hold a value of true or false, true meaning that execution was successful. Let's assign this to script success at the end of our script. Now click Close to close the editor. When you are finished designing the script, you should add some meaningful name to it. This name will be used as a reference through the application to the Visual Script. When you created the script, the default name of new vscript was assigned by PGT. To change this default name, double-click the empty space in the editor to open the General Script Properties editor. At the top of the editor, you can change the name. The name of the script can only contain alphanumeric characters and some special characters like underscore or a dot. Space is not allowed in the name field. Now click OK to close the editor, then select Save from the script context menu. When you are designing a script, the editor is in design mode, which is also displayed on the status bar of the editor window. In order to run the script from within the editor, you must first switch the editor to debug mode. To do so, select the Switch to Debug mode from the script context menu. The actual mode in the status bar will be updated to reflect the change. To make a bit more space, let's move the editor to the right. While the script is in debug mode, you can launch the script using the Run command from the script menu. Clicking Run will open the Generate Script window. To select the script targets quickly, click the button Add from Favorite Hosts. This will open the favorite host picker, displaying the full container hierarchy. By ticking a container, you can select all the hosts and the subcontainers in that container. Now select all hosts by ticking the top-level container. Closing the selector window, you can see that the script targets are populated now. As you open the script generator from the Visual Script editor, the script name is also set in the command section. By clicking the Edit Command button, you can see that the script reference is set in the Custom Action ID field. The name of this field equals to the name of the Visual Script in the editor. Click OK to close the command editor. Now all set and we are ready to generate the execution script. So click the Generate Script button. The execution script appears in a new scripting form. Change the size and the layout of the form for a better view. Each line of the execution script contains connectivity information like jump server to use, the vendor name, management address of the script target, and also the connection protocol. The command column is empty in the script because we do not have any static CLI command to use, but rather a script reference is set in the custom action ID column, pointing to the Visual Script opened in the editor window. Now we are ready to start testing the script by selecting the Execute Now menu item from the script context menu. Click Yes to confirm you really want to launch the script now. PGT will start making connections according to the execution script and will call into the script referenced by the custom action ID column. You can follow visually the execution flow inside the Visual Script you designed. In the scripting form on the left, you will see the terminal output as commands are executed. Let's scroll the view to the right a bit and make the command result column wider to see the data there. As you can see, this column contains the text value we constructed in the Visual Script and assigned to the action result variable. To have more insight on script execution and actual variable values, you can set a breakpoint on any element in the script. The next time execution reaches that element, the script will be suspended, and you can peek into its internals. Now double-click the stop element and switch to the main code tab. By hovering the mouse pointer over the action result variable, its actual value will be displayed in a tooltip window. In this example, the action result variable is empty, which is expected if you take a look at the highlighted execution flow, because not any command element was hit, meaning not any routing protocol was detected on the actual device. Now click Cancel, then Yes to close the command editor window. To resume the script operation, open the Visual Script context menu and select Continue. You can see in the scripting window that the execution script will proceed to the next element. The next time the breakpoint is hit, we expect some value in the action result, as both the OSPF is running and BGP is running command elements were highlighted, setting the text OSPF and BGP respectively. Let's open the command editor of the stop element again, switch to the main tab and check action result value. As you can see, it is matching our expectation now. You may wonder why action result value is not yet formatted according to the code, that is, beginning with the expression protocols running. The reason is that the breakpoint was hit before the execution of the main code. This behavior is controlled by the execution policy of the command element and the global breakpoint setting. Refer to the user's guide to see how the combination of these settings affect breakpoint behavior. Before closing the editor, let's remove the breakpoint from this element. When the editor is closed, you can see the breakpoint has disappeared. Now click Continue to resume script execution. When the script is finished, you can check the detailed execution log by switching to the Process Log tab of the Visual Script editor. If you are uncertain why the execution flow is not as expected, you can check in the log how the connectors are evaluated to select the next element in the script. If you see a yellow warning or a red error icon, it is worth checking the root cause of that issue. When you have finished the script development, you should save the script for the last time to make sure all changes are committed. At this point, you have a tested script you probably want to use several times. In this example, you could run the script until now because it was opened in the Visual Script editor and switched into debug mode. But let's see what happens if you close the script editor and then retry execution. PGT will start connecting to devices the same way as earlier, but when tries to invoke the script referenced by the custom action ID, an error message will appear stating the appropriate custom action handler, or a script in other words, was not found. This is because the name protocol check is unknown at the moment by the scripting engine. Click Now to stop the execution for now. What you will need to do is to register the script with PGT as a custom action handler. You can do this several ways, and for this example, let's reopen the script in the Visual Script editor. Then, from the editor context menu, select the item Register as Custom Action Handler. A message will appear confirming that registration was successful. You can safely close the Visual Script editor now and start executing the script, which will work without errors this time. The other option to perform script registration is opening the application settings from Tools Options menu item and going to Custom Action Handlers configuration item. Here you can see all the scripts registered with PGT and remove them or add new scripts as required. Adding the same script again with the same name is not allowed. The quickest way to deploy a registered script to selected script targets is done by using the terminal window. Simply select the desired container or multiple hosts individually in the terminal window favorite host tree. Then, from the context menu, go to the Generate Script for current folder, then select the script name to be deployed. The Generate Script dialog will open with all parameters pre-selected, and you only need to click the Generate Script button. Then click Execute Now. That's easy, all it is. Thank you for watching this short tutorial. Should you have any question, please feel free to contact us at pgtnetwork.com/contact. We will be happy to assist you.